Okie dokie guys, welcome to the week 3 summary. We're going to have a look at 4 things today, or 4 main kind of topics. The first would be expanding brackets. A nice quick example there. The next thing we'll look at is linear equations with just one variable. Then we'll look at linear equations with 2 variables. And we'll look at solving them in 2 cases. The first of which is when you're given the value of one of the variables. The second is when you've got not given the value of either of the variables, so we can use simultaneous equations in that case, and we can use substitution and elimination depending on the situation. Then we'll just have a quick look at word problems. So let's get started with expanding brackets. So that's one. So this is a kind of a pretty simple one. We're just going to look at the following example. If we've got 3a times a plus 2. So the question is, can you express it, or if you're told to expand it. So expansion just means essentially get rid of the brackets. And what we've got to do in this case is we've got to take this whole term and multiply it by this, and also multiply it by this. So we take 3a times a. Well, what's that? 3a times a plus 3a times 2. Now, I guess a good way to think about this is it's easiest to express things if we, well, we can also think of this as 3 times a plus 3 times a times 2. And what we're going to do is we're going to multiply these. We're going to do this multiplication first, and we're going to do this multiplication first. So this is kind of keeping our a's together and keeping our numbers together. So a times a is just a squared, and 3 times 2 is 6a. And that's how we're going to express it. So that's a really long-winded way of just saying that 3a times a plus 2 is the equivalent expression to 3a squared plus 6a. Cool, so that was just expanding brackets. Next thing is linear equations in one variable. So let's consider an example again. Let's consider the equation 4k equals 40. So this is a linear equation. There's one variable, and hopefully it's pretty clear for you to see that if you divide both sides by 4, because we've got 4 times k. K is the thing we want by itself, so we just have to divide both sides by 4. Again, if we have 4k divided by 4, top and bottom just cancel, and we just end up with k equals 40 divided by 4. Whoops, that's not what I want. It's also not what I want. 10. So that's that, and that's, you know, essentially pretty easily. That's our first example. We can look at another example here. Example 2. That could be something along the lines of 5e plus 7 equals 29 minus 6e. So again, trying to solve an equation or try to find the value of e. We want to get our e's on one side and a number on the other. So we could do lots of things first. We could move the 29 over that side, or we could move the 5e over that side, or the 6e over that side. But first thing we're going to do is we're going to move this 7, this positive 7, over to the other side by subtracting 7 from both sides. So plus 7 minus 7 equals 0. So it's 5e plus 0, which we just write as 5e. And then 29 minus 7 is hopefully 22. And we keep our 6e the same. Now we'll try and move this 6e over to this side. Opposite, or the inverse thing of taking away 6e is to add 6e. And so we end up with 11e equals 22. And then again, similar to this situation where we've got a number times the variable we want, we just divide by that number. Equals 2. So yeah, So that was just linear equations in one variable. Now we're going to look at linear equations in two variables. First case is when we're given a variable. Okay, so the standard form of a linear equation is y equals mx plus c, where m is the slope, rise over run, or steepness if m's big and positive. Look like that. M equals positive and small, something like that. M equals negative and big, something like that. That's obviously on a set of axes, something like that. So that's our general form. And now, but obviously, this c is a constant, and our variables are our x-axis there and our y-axis there. So first equation for 3a could be something along the lines of 2p equals 3q minus 7 when p equals 4. That's a bit messy. When p equals 4. So all we have to do here is to take our 4 and put it in where the p is. So 2 times 4 equals 3q minus 7, and then 2 times 4 is obviously 8, equals 3q minus 7. Move the 7 over that side by adding 7 to both sides, and so you just have 15 equals 3q. And then there's a q, again, same situation as before, we just divide both sides by 3. And we have 15 divided by 3 is 5 equals q. We can call this equation 1, and so we sub q equals 5 into 1, and that gives that 2p. Oh no, so what I was doing there was I was trying to find out the value of p, but obviously p is 4, so don't need to do that in this scenario. Okay, so that was linear equations, two variables. When we're given a variable, now we're going to look at simultaneous equations. So that's B. B, so simultaneous equations. What are simultaneous equations? Essentially just two equations with, that's shorthand for with, I'm going to use it from now on, same two solutions. So, you know, if a normal linear equation looks like that, simultaneous equations is when we have one linear equation and then another linear equation, and the solution that we're talking about is there. So that's a set x value and a set y value, or a set p value and a set q value, or whichever variables we happen to be using. So i.e. same x, y values, e.g. 2, 4, 1, 2, 1, 2, 3, 4, something like that. So we've got two equations representing two different lines. They both intersect at the same point, and we've got some simultaneous equations. And so we want to solve together, i.e. at the same time. And there's two ways. Substitution and elimination. So first we'll look at substitution. I should get some different colors going in here, shouldn't I? That could be that one. That could be that one. Okay, so substitution. For example 1, imagine if we have equation something like 4x plus y equals 8. And we're going to call that equation 1. And we can rearrange. And say we've got another equation, which is 5x plus 3y equals 59. And so these are two different equations. They're going to represent different lines, and we're going to find the point that they intersect. That is the point where they have the same x and y values. So the first thing we notice here, and the first thing that gives us the hint that we want to use substitution, or that substitution is going to be a pretty easy method, is the fact that the y here is by itself. So it could be the x by itself or the y by itself, but by itself. And that means that in a couple of easy steps we can have the y on one side, or actually in this case it's one step. So rearrange, which is take 4x from both sides, which gives us another equation. So this side minus 4x equals just y, and then we've got 8 minus 4x, and we can call this equation 1a. And then what we can do now is say, well actually, look, this y is the same as this y, so we can just take this and substitute it in for this y. And so what we end up with is 5x plus 3 times this whole thing, 8 minus 4x, which is just another way of saying y equals 59. So why was that helpful? Well, when you've got an equation that has two variables in it, you can't do kind of the simple algebra that we did up here, or that we did up here, because see, there's just one variable. We can get straight down to that variable equals a number. But if you've got two variables, two unknowns, you can't just go straight there. So we've essentially substituted in the expression, an expression for y in terms of x. Y in terms of x is this. So we've substituted in y in terms of x to this y. So now we've got an expression with only x's, which makes us happy because we can solve it. So now we just have to expand these brackets as we did before. 3 times 8 would be 24. 3 times negative 4 is negative 12. See, and it's okay if you take a little time with your times tables. Equals 59. And now we want to combine these x's, so you keep your apples with your apples, x's are apples, and your oranges with your oranges. Our oranges are our numbers. So 5 apples take away 12 apples is negative 7 apples. Keep our 24 there. And then we can take 24 from both sides. And we end up with negative 7x equals 35. And then we have to just, again, we've got a situation where it's a number times an x, and we notice in this case it's a negative number, so we want to divide by the negative 7, and we end up with x equals 5. And so now this is when we do a cool thing, because now we've got the x value, so it's going to be x, y becomes 5y, but we've still got to find y. So what we do now, sub x equals 5 into equation, well, if we substitute into 1a, that makes it pretty easy, doesn't it? 1a. And that gives, I've forgotten 1a. y equals 8 minus 4x. Y equals 8 minus 4x becomes y equals 8 minus 4 times 5. So y equals 8 minus 20. So y equals, I think I did, made a mistake. 35 divided by negative 7 is not, that tool that I don't want, is not 5, it's negative 5. Rookie error. So y equals, is that the color I had? It's not the color I had, that's the color I had. Negative 5. Negative 5. Negative 5 plus 20 y equals 28. So now we want to check sub the point 528 into 1, equation 1 or equation 2, doesn't matter, or equation 1a or whatever, but it's good to go back to one of the original ones. 4x plus y equals 8. 4x plus y equals 8. So we've got 4 negative 5 times negative 5 plus 28 equals 8. 4 times negative 5 is negative 20. Don't forget your negative signs. Equals 8. 28 minus 20, or negative 20 plus 28, is equal to 8. Tick, tick. All good. So that's substitution. And again, you use substitution when we see one of the variables by itself, then we can easily and quickly rearrange, and then for one variable, y in this case, in terms of the other variable, and then substitute that into the second equation. Okay, so now we're going to look at elimination, which is 2, which is this color. So what question do we have here? Here, think of, we've got two equations here. 4a plus 3b equals 24. We're going to call that equation 1. And then 7a plus 5b equals 72. Call that equation 2. Now we're going to rearrange. We're going to times this one by... Okay, so the idea of elimination is to get two of your apples or your oranges or your pears or whatever. So if A's are apples, B's are bananas, and numbers are just numbers. We want to get either the same number of apples, so 4 and 4, or 7 and 7, or, I mean, what's a common factor here? Or we have 28 of these and 28 of these, because 4 times 7. Or we want to get the same number of bananas or B's, so that we can kind of cancel them out through some process like addition or subtraction or something. So it's probably easy to multiply things by 5. We can multiply this by 5, and that'll give us 15 of them, and multiply this bottom one by 3, and that'll give us 15 of them. Then we'll be able to take them off, but we have to multiply the whole thing. So 4 apples multiplied by 5 is 20, as I said, plus 15b equals 24 times 5. Well, 5 times 25 is 250, and then we have to subtract 5, so that's 120, and then we just take, and then we can call that equation 1a, because we've modified a, and then 7 times 3 is 21, a plus 15b, these are the ones we're going to cancel, equals 216. So again, I'll just circle this to make it easy to remember later. These are the same. And we can call this equation 2a. And now we're going to say 2a minus 1a gives, so 21a plus 15b equals 216, and 20a plus 15b equals 120. Subtract. So I'll just put this in brackets so that we know we're subtracting the whole thing from the whole top one, just to make it clear that it's not just the first term, so it's not just negative 20a plus 15b, it's minus the whole thing. So 21 apples take away 20 apples is just 1 apple left. 15 bananas take away 15 bananas, you don't have any bananas at all. And 216 minus 120 is 96. So a equals 96. Great. And we can sub this into equation. Don't even have to write equation. Let's be lazy. Let's just say sub it into 1. And so we've got our 1 there. Try to keep that on the screen. And so we've got 4 times, which gives us, this is kind of like a gives us sign that ends up looking quite messy. 4 times 96 plus 3b equals 24. So that's when we sub our 96 there into there. Four times 96. So 4 times 100 is 400, and then we have to take away 16, which is just 4 times 4. So that equals 384 plus 3b equals 24. Then to get the b's by themselves, we can just take away 384. I should probably do that in indifference, move it over a bit, just so it's clear that it's not part of the equation. Cool, and then so 24 minus 384 is, I hope, 360. Oh, negative 360. And then we can divide both sides by 3. Should be pretty familiar with this situation with something times a number and dividing both sides by that number equals negative, don't forget your negative sign, 120. So therefore, it's good to write a concluding sentence. The simultaneous solution is, what do you reckon? 96, negative 120. And so if you've got a graph of, in this case, A and B, we've got 96, 96, and negative 120, negative 120. So our point's going to be here. Cool. And then the last thing we were going to have a quick look at, if we can find our way out of it, was word problems. Oh, I went back to the original color. No, I didn't. It's slightly different. So all we were going to say about this one was, again, a little approach. So the first thing is identify variables and choose pronumerals. So, you know, if we've got an example like Ollie, for every hour that Ollie does homework, okay, if Ollie does no homework, he'll get 5 marks on the test, or 5% on the test, and for every hour he does, he'll get an extra 2%. So we'd have marks on the test, which we could call M or something like that, or percentages as P, and then we've got hours, so we'd have an H. Probably. How? So this is keywords. So things like for every would be a multiplication, or he gets an additional. You have to make sure you added an extra one for every other unit. So yeah, but it's just really a matter of practice. 3, help yourself, which is just organization. 4 is calculate, and 5 is check. And so we showed a really good check here where we just kind of checked by subbing our point back into the equation. And again, we could have done that with the simultaneous option as well. So yeah, hopefully that was helpful, and see you next week.